Welcome back to the Rap History of the World. Act 1, Part 2 coming up tells the story of life on Earth. If you remember the end of Part 1, we had rocky planets with water on the surface. In 2014, scientists actually discovered proof that water once existed on Mars. It's not there anymore and there's no evidence that life ever existed. In the rest of the universe, there are about 10,000 billion stars. Many of these might have planets with water or even life. We just don't know. So that's why the rest of the story takes place here on Earth. Part 2 coming up begins with the origin of life and then tells how evolution drove the development of more complex and more diverse biological forms, from bacteria in the oceans to large animals on land. If you're ready, let's go.
And so it came to be that on one of these, amid the primal seas, a dash of energy like CHN and SMP, making amino acids, RNA, DNA, the base, the base of everything alive today, chopped in a membrane forming long chains, and information store and self-replicator, mutate, replicate, innovations can accumulate at a rate that fascinates. Ribosomes, chromosomes, meiosis, osmosis, a million chemical tricks, turning rocks, water, air into trees, lungs, and hair. Diversification follows descent with modification and non-random elimination of all but the best adapted. I just read that. Producers and consumers and biotic communities, tectonic cycling minerals of life-building chemicals, forming mechanisms of feedback, a global thermostat that began to stabilize what's in the seas and skies and gave rise to the blue marble that we marvel at. Lovelock called it Gaia. These rhymes are on fire. 3 billion years of the single cell, they done well, but life went further when bacterial merger made the eukaryote of historical note. Horizons open far were multicellular. About 500 million years ago, deep in the oceans, a Cambrian explosion set in motion a great radiation of prey and predation. Things to help swim like fins and branching limbs, teeth, claws, grasping jaws, sensory perception, evasion and deception. The arms race continued at pace forever, 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 ever. And life passed with distinction, 5 mega extinctions. From without or within, the atmosphere is thin. Asteroid interruptions, volcanic eruptions, once or twice. It's been covered in ice. But after adversity comes fresh diversity of the branches of the tree leading the recovery. And so it came to be that creatures of the sea would crawl onto land and would quickly expand. From amphibians to simians and lots between, we've seen colossal among the fossils were dinosaurs. Once ruled the world, today they survive only as birds. While mammals rise late to dominate, to dominate. So we've seen the creation from random generation of new entities and even environments, driven by selection against the direction of entropy. So it grows, life's magic tree. But is the point mutation the lord of all creation? What about epigenetic methylation, chromosome hybrids, bacterial plasmids? A lot of what's inside us got here by virus. So maybe part of the answer lies in horizontal gene transfer. And note the propensity to increase in complexity and energy flow density. Evolution can operate on systems small and great, the particles, the chemicals, cells, plants and animals. The trends transcend different realms. Will they hold true for human worlds too?
So that was Act 1, Part 2 of the Rap History of the World. Thanks for watching and I hope you enjoyed it. Part 3 will tell the story of human evolution. Now, there was a lot in there and I hope you were concentrating. If you'd like to find out more about the different topics, have a look at the website, raphistoryoftheworld.com. It'll also tell you the articles and books where some of the ideas came from. I won't go into too much detail here, but I do want to talk about some of the recurring themes that we can hopefully see by now. More than once we saw that new complex forms emerged from the dense interactions among their component parts. So for example, in the center of stars, hydrogen atoms under great pressure fuse to form larger atoms and so on. But also in the early oceans, small organic molecules called amino acids, trapped inside tiny cellular structures in very large densities, were able to recombine with each other in lots of different ways until eventually they formed long chains which had the properties of self-replication. Then we met the evolutionary process. Remember the lines, descent with modification and non-random elimination of all but the best adapted. That's called the Darwinian algorithm. If something can make copies of itself, and there are differences between the copies that affect how likely they are to survive and make further copies of themselves, then the force of selection can act to drive development. And this kind of reproduction, copies of copies, involves what's called the vertical transmission of information. And innovation comes from random errors in the copying process. But we also discussed ways that evolution can be speeded up by the horizontal transfer of genetic information or by symbiosis. Symbiosis means when different organisms live together in a functional unit, like our gut bacteria or the eukaryotic cell, which formed when one type of bacteria began to live inside a larger cell permanently. In terms of horizontal transfer, we know that bacteria exchange genetic information via their plasmids, and by the way, that's a problem when they evolve resistance to antibiotics. More recently, some scientists have argued that viruses have actually managed to integrate themselves into host genomes, viruses in your DNA, but that they play functional roles in the development of the organism. Now, in particular, those comments about viruses are a very new area of science, and it would be too soon to say with any certainty that viruses played an important role in the evolution of animals, for example. But it is becoming increasingly clear that evolution has been greatly accelerated by different methods of acquiring and exchanging genetic information. So we talked about dense interactions and information exchange. Look out for these again in Acts 2 and 3 on human history. The two major milestones in human history are the agricultural revolution 10,000 years ago and more recently the scientific revolution. Both these events took place in parts of the earth that were densely populated, but were also particularly well connected internally with their neighbours and beyond. These are the arguments of David Christian in his book Maps of Time. Finally, a note about complexity and energy flow. The eukaryotic cell is larger, more complex, and more powerful in terms of energy consumption than a bacterial cell. Similarly, plants and animals consume more energy than do single-celled life, even when adjusted for size and mass. A more surprising result is that many forms of life can actually process more energy per unit mass than do stars or galaxies. These calculations have been done by Eric Chaisson in his book and website, Cosmic Evolution. Chaisson argues that the rise of complexity and rates of energy flow are long-term trends in the history of the universe and continue with the development of human agriculture, civilization, and technology. But we're getting ahead of ourselves. At this stage of the rap history of the world, humans don't even exist. The story of how we evolved from the last ancestor we shared with the other great apes is up next in Act 1, Part 3. I hope you'll join me there.